On today's episode, Samsung doubles down on Texas IC production, and GM raises the stakes in battery innovation. Today's episode is brought to you by Engineering.com, a globally trusted source for engineering content. Check out this and many other exclusive videos for the engineering professional found only on Engineering.com TV today. The global integrated circuit shortage has crippled auto production everywhere, and as the COVID crisis improves, demand for cars and light trucks is increasing. But dealer inventories for many popular models are minimal, and incomplete vehicles are piling up in assembly plant storage lots all over America due to the shortage of critical integrated circuits. COVID-19 again is the cause, as the IC industry reacted to the sudden drop in vehicle demand by switching operations to personal electronic device components for smartphones, tablets, and the rapidly increasing number of smart wearable devices. Now more chips are on the way, however. Samsung Electronics is rumored to be ready to invest $17 billion in Taylor, Texas, for a massive semiconductor operation the firm calls the STAR project, according to an inside source quoted by Korean media outlet the Junang Ilbo. The Central Texas project is expected to operate 6 million square feet of facilities, making it approximately 3 times larger than Samsung's existing manufacturing plant in Austin. Although not officially announced by Williamson County officials, over $300 million in tax breaks over the next 10 years have been tentatively approved. Construction is expected to begin in 2022, with operations starting 2 years later. Over 50% of the world's advanced semiconductors are manufactured in Taiwan, led by the Taiwan Semiconductor Manufacturing Company, TSMC. The limiting factor for production in the semiconductor industry is foundry operations. Many integrated circuit makers are fabless, meaning they design and market chips which are contract manufactured by others. The new Samsung facility will be a foundry, and like Austin, will likely manufacture very high-density, single-digit nanometer gate devices, probably alongside 14-nanometer technology as used in Austin. As a foundry, Samsung makes devices for many customers in many industries, and automotive integrated circuits usually don't require the highest densities or lowest power consumption, making this market ideal for pre-existing lines as high-performance demands from smartphone and personal electronics makers push the boundaries into newer technologies. With renewed interest from companies like Apple and US-based manufacturing, however, automakers will still be working in a seller's market for semiconductors for the foreseeable future. In 2 years is a long time to wait. If you like this show, be sure to subscribe to our channel and click on the notification bell for our next episode. Another area of automotive technology that won't wait is advanced batteries. General Motors has announced a new facility designed to significantly expand the company's battery technology operations. Called the Wallace Center, the operation will be built on the campus of GM's Global Technical Center in Warren, Michigan. The center will be used for advanced battery and cell development and to integrate devices developed by GM-affiliated companies. The primary goal of the facility is to achieve battery cost reductions of at least 60% compared to the current generation of GM Ultium batteries. Technologies expected to be prominent include lithium metal, silicon, and solid state. GM expects to develop new generation cells in form factors at 1 meter scale, about double the size of current Ultium pouch cells. The location in Warren will allow the new center to easily collaborate with current battery research programs run at GM's Research and Development Chemical and Materials Subsystems Lab and the Estes Battery Systems Lab, the largest battery validation lab in North America at more than 100,000 square feet. This will allow in-house durability testing of cells, modules, and entire battery packs. Besides battery technology, the center will also develop battery manufacturing techniques for GM plants as well as the company's joint ventures with LG Energy Solutions in Lordstown, Ohio and Spring Hill, Tennessee. The company holds 2,000 EV-related patents and expects to use 60 patents and trade secrets and another 46 patents pending in lithium metal electrolytes, anodes, cathodes, and binders. The development of very large format cells may prove pivotal. Most major battery makers focus on devices for personal electronics, and so far technologies aimed at increasing energy density have been developed primarily for that market. Will automotive very large-scale cells operate outside conventional scaling laws and emerge as unique chemistries and production technologies? Well, with all the major automakers now either developing battery technology in-house or partnering with firms that do, it's clear that OEMs are unwilling to risk dependence on their Tier 1 supply chain to deliver batteries. The winning technology may define which automakers survive in the first half of the 21st century. Well, that's it for today's episode of This Week in Engineering, brought to you by Engineering.com. For our Deeper Engineering series, visit engineering.com TV for exclusive shows like Manufacturing the Future and Designing the Future, not found on our YouTube channel. The links are in the description below. Thanks for watching.